let's finish up what we left over from the previous video. So after we create our first chart, that's the age against the population in 2019. If we want to add a label on that, because by default you can see they have the x-axis title and the y-axis title. If you want to add a title for your chart, so one thing you can do is we can just add a comment, especially in Jupyter Notebook. Each cell and output, they are next to each other. Or the second one, after we get our chart, we can print. Okay, so that's why you see here they will display the US population, then your chart display. The third way you can do is we can add the title to our plots. Okay, so that's like this one here. You can just using the plots. After you just create a plot, then you use the plots.title. Then they will add the title to the previous plot you just made. Okay, so then we see here you will have your title of your plots on the top of that. So that's our first chart. But we can do more on that, right? So here is in 2019 for all different age, the total population. How about we continue to do that to see the population using the males versus the female? Yeah, so let's compare the male and the female according to their age. So that's why here the first thing we need to get the male for all different age. So the same thing we get earlier, we have the non_999. That one is without the total for all the age population. So that's just get the male. So where the sex equal to 1, we just get those information. But if you remember here, if we made the chart just like that, okay, so they have to show. So let me comment out this one first to let you see the output. Okay, so that's why here you see they have the 2014 and 19, and they have the age. Yeah, so if we just choose the sex equal to 1, remember they will still have the sex column. So that's why here we just drop the sex column. We only have the age and the year of the population. Okay, the same thing we do for the female. So that's why we will have the male and the female data with the age and the year of population. So afterward, we want to create a table and actually only contain the male population and the female population. And also that's just do the 2019. So that's why let's create another table. We call pop 2019. So that's a new table. So the data we need, the column we need, of course, we still need age. Okay, so then the second column, we will have the male population in all different age and the female population for different age. So earlier when we create the males and female, because they both have the 2014 and the 19 population, so we only get the male column. You see that's the array. So then the female that column, that's the array of the 2019 population for female. Yeah, we still need the age. So this one either using for the males or female, they are both okay. So that's our 2019 table. Okay, so right, see here is the age. Here is the male and the female. Yeah, like we say, you can see the number from tables, so you can compare one of each other. Or they have mostly the younger age, they have more males. But one thing is, it's good to show in the table, but if you can visualize to make that in the graph will be much better, right? So that's why the second chart we want to use. Okay, let's make our second chart. So in this chart, we will show a little different. So we want to have both the male and the female population. So in this case, if you have two different attributes you want to display in one chart, we only need to specify the x-axis. So all the other column, or we say attribute, they will plot in a single line. that will be in the visual line. So that's how they look like. Okay, so that's why here we have the age, right? So the population, again, that's the million. So you can see they're using different column. They have different line to represent for that. The male will be the dark blue. So the female is in yellow. So yeah, that will be easier for us to observe the attribute, right? The distribution, right? So that's why you can see before the maybe age 30, we have more male population than the female population. From 30 to, yeah, they are all kind of next each other. So until 50, they kind of, yeah, the same size. So then after 50, yeah, you can see the yellow is above the dark blue line. So above, we can kind of observe about 50, the female population is more than the male population. Yeah, you can pause the video to see what else you observe, then discuss with your group, or you can send the post the question in the discussion. So that's the total population for the male and female. Then the next example, that's the how about we make the percentage for the female for different age. Okay, so that's why we have the female population. So if we can get the total for the male and the female, using the female divide by total, we got the percentage. Okay, so that's why here we will calculate the percentage for female for different age. Okay, so then the same thing, let's get the total first. So here we have the column males population plus the female population. So the total will be the whole population for all different age. So this one, the same thing, that's an array. So that's why we're using the female population divide by total. They will be two array divided by each other because they are same size, this fine. So after you divide, there will be a decimal number. So we want to see the percentage, so we multiply by 100. So let's see how they look like. Okay, so that's our percentage. So that's the percentage for different age. So that's an array. Okay, so you can see the decimal actually is a lot. We don't need that much decimal. So if you want, you can round to. So since this one is an array, we use the NumPy. So you round to the percent female, we do the third digit. Okay, so then you will see here, they only have the third digit. I think that's enough. So either way, you want to round to the 1 digit, 2 digits, 3 digits, that's all up to you. Again, that's array. So if we want to make a chart or compare, it's better we use a table. So that's why let's create another table. But this table, yeah, we're still using the POP 2019. So then we just add one more column. We call the percent female. Okay, so then you will see the new POP 2019 table become like this. Now we have the percent female. Yeah, if you want, of course, you can add the percent male. So then, yeah, you know how to do that. We'll leave that for you. So here we just see the example if we want to plot a chart, how they look like. So this one, we only want to see the age with the female percentage. So that's why we specify the x-axis and y-axis. Okay, so then you see that. Okay, so I want you to see, did you see any question or doubt about this chart? Pause the video so you have more time to observe. Yeah, they have found 50%, right? So you can see 50% above, that means you have more female. But one thing is, you can see this chart, actually, they start from 0. They kind of just jump to 50. So if you want to change the scale for the x-axis or y-axis, yeah, we can do that, okay? So we'll have this one still the plot. So then we just change the limit. Okay, so this one is y-axis. So we change the y limit from 0 to 100. So then you will see they kind of just shift. But it's up to you. See which way you want to display to be more meaningful for your demonstration, for the visualization. Yeah, we see that's the line chart example. You can see they are the x-axis for age. They have the order. Yeah, see from 0 to 100. So the next one, we want to show you some scatter plot. Like earlier we told you, line chart, your x-axis, they have the relationship. They kind of increment by order. But scatter plot, usually they don't have that relationship. So we see this example is we have another text file. So they have all the actors, movies number, and the total gross. So we read this file, then we create, we get the actor chart. So you can see they have the name of each actor. They have their total gross. So this one, yeah, I'm not sure which year, they didn't say that. So actually they told you how many movies they made and the total gross. So that's why if you divide by 41, that's the total gross divided by the number of movies, you got the average for each movie. So this one, if we want to make a chart, yeah, so you can see here the player actually, they cannot like in the increased order in the x-axis. So that's why just like NBA player example, if we want to make the chart, we may need to make a scatter chart. Okay, so this scatter chart, we don't need to know which actor, but we just want to see the distribution for all the data. So for example, now we have, we choose the number of the movie. We see the number of movie and the total gross. Supposedly, right, usually you have more movie, you have more total gross, right? But let's see how they look like, okay? So if you want to make a scatter plot, you just do the table name .scatter. Specify your x-axis and y-axis. So we see here. Okay, so that's the distribution. Okay, so like earlier we say, if the number of movie really have a higher growth, they will be increment like this, right? But not really, right? Okay, so again, the same thing. Pause the video, see what you observe from this chart. The same thing when I record the video, the same thing. I will pause. I will see how they do that, how the information I will got to share with you. Yeah, so we can see actually the highest growth, actually, they only make like about 40 movies. So then when the actor have almost 80 movies, the total growth is not really the highest one. Okay, so even this only maybe just less than 5 movies, they have the similar total growth. So that's just the distribution we want to see how they look like. So then the next one you can do is the total growth maybe not represent enough. So maybe we see the average for per movie growth. Okay, so that's why we make another scatter, still our scatter, because they don't have relationship for the x to the x-axis. So then we see here, yeah, so then if that's a per movie, so that's why the same thing. Yeah, actually kind of is this way, right? The slope is kind of negative. Then kind of more movie you made, your average movie growth is kind of slow, smaller. Yeah, so that's interesting, right? Okay, so what else you can observe? Yeah, that's very interesting. You see, actually the high is 3 average for per movie. They didn't really make that much movie. Okay. Yeah, so actually we have 1 is here. So then you can see, we see which actor actually made above 400 just 1 movie. Okay, so that's Anthony Daniel in Star Wars. You know what's that? They only have 7 movies, but the average is the highest one. Yeah, I don't know what's that either because I don't watch Star Wars movie. But here, let's show you who it is. That's Anthony Daniels. Yeah, like I say, I don't watch the Star Wars movie, but I know him as well. Okay. Yeah, so that's our scatter example. If you want, we provide you the text file after you create the table. Yeah, you see the distribution, you see the content for the table. Play with those columns if you want to create more chart.